In this video, we're going to learn how to graph quadratic functions that are written in vertex form. The vertex form of a quadratic function looks like this. A parentheses x minus h, the quantity squared, plus k. And a can't be 0. Otherwise, it would be a constant function. Okay? So we're going to learn how to graph this in just a few steps. And in the step 1, we're going to look at the vertex. That's the lowest or highest point. And the vertex in vertex form is actually very easy. It's just hk. And here we have h. And for us, that number is 2. Okay, remember to switch the sign. So that's 2 for the x coordinate. And the y coordinate is the number that's added out here, which is k. And in our case, that number is -1. So the vertex is 2, -1. In step 2, we write down the axis of symmetry. There is a symmetry over a vertical axis that the graph can fold over. And that equation is given by x equals to the x coordinate of the vertex, which is 2 in this case. So x equals 2 is the axis of symmetry. Okay, great. In step 3, we're going to look at the sign of a. A is the number that is multiplied by the square quantity. In our case, that number is half. And so a is equal to half, which happens to be positive. So in this case, the shape of the graph would look something like this. Okay, so let's consolidate all this information and say that concave up. And let's consolidate this information by starting to sketch our coordinate axes and put in the information that we currently have. So here we have the coordinate axes. Okay, and maybe we can move this up a little bit. Okay, and so the first thing we're going to do is we're going to graph the vertex. The vertex is the point 2, -1. So let's say this is 1, and this is 2, and this is -1. So we're going to put the vertex right here, and we can label it. Okay, great. And the next thing I'm going to do in purple is I'm going to graph this axis of symmetry, which is this vertical line that goes through the vertex. Okay, so in our case, our vertex is at 2, -1. So this is our axis of symmetry. And I can write that down here. X is equal to 2. That's our axis. Finally, let's label our coordinate axes as x and y. And here we have summarized all the information. Furthermore, in step 3, we know it's going to be concave up. So I'll just put a little arrow up here to remind me that the graph is going to be pointing upward. Okay. All right. So let me take a copy of this and put it on the next slide so we can continue graphing our function. So here we are. All right. In step 4, what we'd like to do is we'd like to get 4 more points. Okay. So in order to do that, what you'd like to do is you'd like to pick 4 x values, but we're going to pick them in a very specific way to make our calculations easier. Okay. For the first 2 x values, what we'd like to do is starting from our vertex, we'd like to go 1 unit to the left and 1 unit to the right. So in this first setup, we're going to go 1 unit away from the vertex. So for us, if I were to make a table here, so here we have x and here we have y. So for us, 1 unit to the left would put us at 1, and 1 unit to the right would put us at 3. And this is 2 of the 4 points that we're going to pick. And I'll draw a line here. Okay, now going back to this picture on the left, The next 2 points I want to pick are two values, 2 units to the left from the vertex and 2 values to the right from the vertex. So the next 2 values will be 2 units away from the vertex. So let's erase this and this. And okay, so here we're going to go 2 units to the left. That lands us at 0, the x-coordinate. Okay, and next we go 2 units to the right. And that lands us at 4. And these are the other 2 points. Okay, you can get rid of this. So now, to get the y values, we're going to plug in, instead of x in the original function, this x value and calculate to get the y. So if you plug in 1, you end up getting negative half. And because of symmetry and because of the way we've chosen the x values to be equidistant from the left and from the vertex, this value is also going to be negative half. So the nice thing is we don't have to plug in those two numbers. We can just plug in one of them and get the same y for both. Let's now plug in 0. If we plug in 0 into our function, we end up getting 4 times half, which is 2, minus 1 is 1. And again, because of symmetry, at 4, the value is going to be 1. So now let's plot our points. 1 comma negative half is right here, and 3 comma negative half is right here, and then 0 comma 1 is right here, and then 4 comma 1 is right here. So there you go. Now we have 5 points, including the vertex, and that is enough points to get an overall shape of this graph. Remember, it's going to be curved. There should not be any sharp edges. So let's make sure of that. And so here, let's do a better job here. There we go. And here is the other side. And we could put arrows to indicate this is going to go up indefinitely. Okay. In step 5, we want to find the intercepts. Okay. So this was step 4, where we had to pick 4 more points after the vertex. In step 5, we're going to figure out the intercepts. Now remember, to find the x-intercept, you want to find the values of x for which the y value, or f of x, is equal to 0. So for our function, we're going to make the function half times x minus 1 squared minus 1 is equal to 0, and then solve for x. So if you work this out, you get x minus 1 squared is equal to 2. Okay, so x minus 1 squared, or x minus 1 is equal to plus or minus square root of 2. And so x is equal to 1 plus or minus square root of 2. So the two x-intercepts are, labeling it on the graph here, that point is 1 minus square root 2 comma 0. And the other one, which is here, is 1 plus square root 2 comma 0. That's approximately 2.4 comma 0, and this is oh, it looks like I've made a mistake here. Instead of this 1, we should have had 2, because that's the function. Okay, so x minus 2, x minus 2, x minus 2 equals x equals 2 plus or minus. So let's go ahead and fix that. It should be a 2. And so that would be 3. And this would be 2 minus, and that would be 0.4 approximately, comma 0. Okay, so that is how you find the x-intercepts. Okay. Now for the y-intercept, it's actually much easier. For the y-intercept, instead you plug in 0 for the x value. So notice how the 0 is for the function value for the x-intercept, and 0 is for x equals 0 for the y-intercept. Okay, so if we plug in 0 into our function here, so for the y-intercept, if you plug in 0, you end up getting negative, or you get positive 1, which happens to be one of the points we picked. Okay, so we can label that right here, the y-intercept as 0, 1. Okay, so that completes step 5. Once again, let's go ahead and copy all this into our next slide and figure out the last few things for our function. Okay, so the next thing you might want to figure out is what is the domain? Well, the domain for quadratic functions is always all real numbers because you can plug in any real number for x and the function works. Okay, it gives us a value. And so in step 6, we can write that the domain is all real numbers. There's a number of ways to write it. We can write it in interval notation from negative infinity, infinity, or this symbol here, which is the symbol for all real numbers. And the range, well, in this case, the function opens up. So to figure out the range, it's all the possible y values. So we're going to consider the lowest point all the way up, the y values. Okay? For us, shading this part is equivalent to shading this part on the y-axis. So for the range, we have the lowest value is negative 1, and there is no highest value, so that's infinity. So we put a bracket right here. Okay? And finally, let's call this step 7. In step 7, we're going to say whether our function has a minimum or a maximum. Since this function opens up, it actually has a minimum, and the minimum value is negative 1 at x equals to 2. Basically, you're telling us what is the smallest y value and where that happens. Okay? And since there is no max, we're going to say none because this function keeps going up indefinitely. So there you have it. This is how you graph quadratic functions in vertex form and label all the properties of this quadratic function.